Hi friends, so in this video we're going to see about associative containers. In associative containers, the first part we'll be learning about is set or multiset. From the image shown here itself you can understand how it is. In the previous videos we had learned linear diagrams where it was represented in an array or linked list type. Here it is in the form of a binary tree structure, which means that behind the scenes it is implemented by BST form. In associative containers, storage is taking place in three formats. Some of the key attributes of associative containers are they're always sorted by default and follows is less than criteria format. So as earlier we learned in the binary lessons, like less than equal to, here we use less than condition, pushback and pushfront functions. Doesn't imply in associative container. However, we use them. They follow the top to down approach. They will be pushed from top towards down as it doesn't have a double-ended queue. In sets, occurrence of duplicates wouldn't be present and the keys act as unique. The declarations format are represented as set, integer and insert. So here we inserted three datas, 1, 3 and 7 into it. Associative containers have only one of type insertion function. Why I had mentioned it is binary tree is due to its runtime complexity. Associative containers are guaranteed to perform operations of insertion, deletion, and testing whether an element is in it. In logarithmic time is where it will be decreased at the rate of half by half. If you would have, aware of the BST, then you can picture the runtime of it, where it helps to efficiently run the program. So under iterator, we can discover the find function. It will take log of the n and it points to the position of the node for the application. When we compare this with the sequence container, they don't have find member function. Instead, the position has to follow one by one order. In associative container, to do search activity, we use find function. Whereas in sequence container, function of n is being used and it's always low in terms of search. To carry insertion function, use dot insert with position for insertion. While insertion function, we give two pairs. One part specifies where the iterator is inserted and boolean. Boolean helps to confirm whether an insertion activity is being carried out or not. For example, if element 3 has already present in the associative container and we give a function to add element 3 once more, the boolean will give us the return value with a false statement. As soon as the element is being inserted into, the function checks with the return value dot second and returns with false, which eventually points it towards the element 3 and won't insert any key element. In case to insert an element into the exact position we determine, then there is another way. Here we had followed the raw insertion with the number. There is a faster method to follow. The other insertion type is insert, iterate with the element. It follows the short run time and faster methodology insertion to the node. In case the position is not available, it would follow a log of n where elements will be added to the last available position. This gives flexibility to insert anywhere in the nodes. To delete the elements from associative containers, erase functions are used, and to erase element in a faster way is by providing the position of the element with iterator function. Else, if normal way of just specifying the position to erase it, it would take log of n. So importantly, wherever if you want to point the right element, use order of 1, else it will automatically use log of n. So here we had inserted 9 and know its position where it's currently pointing. When the erase function with the position is specified, it deletes the element pointed to 3. Similarly, there is another straightforward way to erase it by specifying which number to be deleted from the elements. This is all about set. So quick recap about sets are, there is no rule for sets. Behind the scenes it runs on binary tree with log of insertion time, search time, and by default it is sorted. Now let's see about multiset. Multisets follow the same functionality as a set, and the only difference is multiset allows duplicate values to be present. It uses same functions of insert, erase, find as, offset, and in iterative read-only modes are being used for node value. Once the node value is being fixed, in between it can't be changed into a different value. So if you try to overwrite the value, it collapses the tree form and creates an imbalanced tree to affect other functions. The properties of multiset are they use fast search operation with the log of n, and next importantly it doesn't allow random access. For example, in vector we can access the element using vector of 1, vector of 2 iterators to read the operations. But here, since it's not been saved in a sequential order position, it will be hard to access using tree structure. So we have to traverse and find the position, else in case if you know the position, direct element can be accessed with location pointing. The next type of associated containers are key value pair. This map or multi-map category containers are known as the true associative containers with two segments. For example, if you check up contacts list in your phone, there are two ways to search. One is by feeding a name to retrieve a phone number, and the other is by entering the number to retrieve the name. Here it follows the same principle by implementing two-way maps. Here the char or the string are used for name and int t to say the phone number a 100. Lazy guys, let me use short films to allocate string and number with make pair function. 200 is shown. Use standard iterators with begin and end function by specifying the position of insertion and the value. Similarly, since it falls under the tree category, here we use log of n to find the position of the element. To show the all the contents in the iterator, use for loop begin with for 1 until for n with iterator dot first and iterator dot second. Iterator dot first consists of key and iterator dot second contains the value. Multimap is similar to map with an addition that multiple elements can have same keys rather than each element is unique. The queue value and mapped value pair have to be unique in this case. Only the implemented pair to multimap are constant char and int. I want you to try changing the key to a different value with iterator dot first as d. So just guess what the output would it be. So that's all about associated containers. So friends, what does associated means? There is always a key and a value pair consists. So thank you friends, and see you in the next video. Bye.